Hello, everybody. I'm David Kopf, the executive editor of Occupational Health and Safety magazine, and welcome to today's presentation, Real-Time Individualized Hydration Monitoring for Heat Injury Prevention. Today's webinar is brought to us by Epicore Biosystems. Many thanks to them for making today's presentation possible. And I'm eager to dive into today's topic, given the increased attention being focused on heat stress and heat injury. And fortunately, we have a very knowledgeable expert for today's discussion, talking about none other than Jim Ryan, Chief Revenue Officer of Epicore Biosystems. He's also the editor-in-chief of the Journal of Business and Artificial Intelligence and a mentor at the Harvard Innovation Labs. Jim has a bachelor's degree from Harvard and a master's degree from Osaka University in Japan. He has spent 30 years building, growing, and operating B2B technology startups around the world. And as Chief Revenue Officer, Jim oversees all aspects of Epicore's sales and marketing efforts globally. He is fluent in Japanese, is a proficient programmer in half a dozen computer languages, and has a private pilot's license. Jim, welcome so much, and thanks for joining us.
Yeah, thank you, David, and thanks for the wonderful introduction.
Oh, hey. Well, it's great to have you here, and I'm eager to dive into our discussion. But before we do that, I want to give everybody out in the audience a few housekeeping items. As you probably saw when you registered, this webinar is part of our executive Q&A program. And in this type of webinar, it's a little different. Rather than having a slide deck and talking over slides, really what we're going to do is dedicate a large portion of this program to answering your questions related to heat exposure and heat injury. And you're going to get direct expert insights from Jim and really tap into his expertise. So consider this a little bit like open office hours with the professor, where you're going to be able to just answer or ask questions to Jim, and he'll be answering him. If you'd like to submit a question, all you have to do is use the Ask a Question console on your screen. And again, you can do that at any point during the webinar. To give us a little structure, I'm going to interview Jim on some topics and some questions related to heat stress and heat injury prevention. And we'll kind of talk about unique challenges, unique technological solutions, and those sorts of things. And I think it's going to be a useful conversation, but we'll take regular breaks throughout the program to answer your questions. If you have any technical difficulties during the presentation, click on the Help button, which is located below the slide window, and you'll receive technical assistance. And lastly, after this virtual event, you're going to receive an email containing a link to an archive of the presentation so that you can go back and review it or share it with a colleague who might have missed it. Oh, and I should also add, we've got some useful resources under the Resources tab of your console as well. Okay, with all that said, we're done with the housekeeping, and we're ready to dive in to our discussion. So Jim, how about we kick things off?
Sounds great. Oh, I should mention, if you stay till the end on the last slide, there's a link to download a heat stress prevention guide. It's completely free, but please stay to the end for that.
Absolutely, yeah, super helpful reference. Okay, so let's start off with kind of our first set of questions, which is really talking about why heat stress is, continuing to be a growing and kind of maybe underestimated, misunderstood workplace hazard when it comes to keeping people safe. So, Jim, from your vantage point, how would you describe the current state of heat-related risk among, industrial work sites?
Well, definitely what we're seeing is heat risk is increasing simply because the temperatures are increasing. We've seen the last 5 years, I think 4 of the last 5 years had record high temperatures in the summer in both the northern and southern hemispheres. We just finished up a really brutal summer in Australia, and the Weather Service is predicting similar high levels of heat for this year as well. So. Definitely, that is a trend that is putting more people at risk. And then, I think sort of ongoing, you have one big risk factor for heat stress is PPE. And a lot of work requires full body PPE. Some of it doesn't breathe very well. Temperatures can get really hot under that PPE. So I think. There's a lot of converging factors, but certainly heat risk has been increasing over the years, and we think it will continue to increase.
Okay. What are some of the overlooked effects of heat stress on workers? Obviously there's really pronounced things like heat stress or heat stroke rather, but are there, kind of other significant, but maybe not as closely monitored issues that workplace safety professionals need to be looking at?
Yeah, I think a lot of the focus has tended to be sort of at the acute end of the what we call the accident chain,
Yeah.
and that obviously it's important to prevent those acute injuries. You don't want people, ending up in the hospital or, even having to, stop what they're doing and sit in an air-conditioned truck or a room for, a few hours because they've gotten so hot that that it's they have an impending injury. But really, I think intervening a lot earlier in the accident chain is something that often gets overlooked. So, as soon as a person becomes even slightly dehydrated, they've lost 500 milliliters of water, 1,000 milliliters of water. You start to see fatigue, and that hits productivity. People get fatigued, they work more slowly, and then as they lose more and more fluid. At around 2% of body weight lost in fluid, they start to experience cognitive impairment and loss of coordination. And this can often lead to other types of injuries. So it can lead to falls, it can lead to crush injuries, it can lead to, trips. And those often aren't reported as heat injuries, but they are the result of that cognitive impairment that happens, at a moderate level of dehydration that the worker might not even be aware. At 2% body weight lost in fluid, you might feel thirsty, but you probably won't be aware of it.
That's wild. And I would imagine that they also could put other workers at risk, real domino effect. Are there certain injuries or job functions or types where heat-related risks are especially, acute, but maybe not as recognized? Like I would imagine that, everybody's got like a vision of a lone worker in oil and gas, out in the middle of nowhere, really baking in the sun. But I imagine that there's lots of other injuries that might not be as obvious as well.
Yeah, so I think, again, here, a lot of the focus has been on either industry or site or job function factors, which are there. But what we've found in the data we've collected now over several years in the field is that some of the highest risk is in unacclimatized workers. So regardless of the job function or industry, when you take people who haven't been exposed to heat recently and suddenly expose them to heat, that's when we see people get into trouble really quickly. And surprisingly, this tends to be more the case in younger workers. So workers in their 20s and 30s who maybe have not experienced serious injuries, kind of very confident, or they feel like, they have to prove themselves, and so they want to just push through it, and they sort of ignore those early warning signs. If you're unacclimatized and you're suddenly working in 100 plus temperatures, and you try to push through it, you could end up in really serious trouble. So I think that's a particular area of focus that people should be aware of.
Yeah, it's sort of that ego versus wisdom battle, that's for sure. So, all right, well, let's go dive into some audience questions. We've got some good ones coming in. Everybody, remember, you can use the Ask a Question console on your screen to ask a question, and Jim will answer them. So, Jim, talking about acute issues, how common are seizures related to heat stress? Are there any studies out there that people might be able to read or review to learn a bit more about these sort of more acute events?
I don't have specific data off the top of my head on seizures. I know that if dehydration is allowed to proceed and core body temperature starts to rise, the effects on the brain, so the brain starts to swell, and that is what leads to seizures. So I don't have data on how often that happens in the workplace, but I can definitely look that up, and we can send that out to the audience after the presentation.
Oh, awesome! And then here's another one. While the focus tends to be on outdoor work, and I imagine when they're saying, well, the focus, of the heat stroke discussion, the heat stress discussion, tends to be on outdoor work. Should we make sure we purchase and use some monitoring equipment for indoor work as well?
Yeah, absolutely, and that's a great point. I think when we think about heat, we think about the weather, and we think about hot, sunny days. But heat exists in the workplace, in many workplaces, independently of the weather. And there are several examples I could give. So in industrial settings that use high industrial heat, so any factories that are working with furnaces, or they're doing casting metals, fiberglass furnaces. I know that pulp and paper uses very high temperature processes. So any processes that use high temperature, especially on top of that, combined with PPE use, those workers are exposed to even higher heat risk than for example, a construction worker working outside on a summer day. And then you just have sort of next level down is a lot of times in the summer when it's hot outside, specifically in logistics and warehousing, a lot of facilities, aren't air conditioned, and so those facilities can get pretty hot inside. So they're not outdoor workers, but they are exposed to seasonal heat. So I think both of those cases are good examples of where you need a good heat stress prevention strategy indoors as well.
All right. Now here's an interesting one. Obviously the overarching topic is about hydration. And we've got our first hydration question. This is an interesting one. Can you comment on hydration stations in area where other hazards, such as maybe chemicals or something like that, are in the area? Would a job hazard analysis or a job safety analysis be sufficient in the area of the hydration station?
Yeah, I think in terms of placement of the hydration station, you definitely want to avoid areas where other hazards are present. And certainly, if it's in an environment where it's difficult to locate such an area, you have to balance it with how far away is it? Because if you put the hydration station too far from where people are working, or if you put it in a different zone where they have to change PPE or remove PPE, then clearly that becomes just a psychological hurdle to going over and hydrating. You don't want the workers to feel like it's a hassle to get hydrated.
Makes
but on the
sense.
other hand, yeah, that is a good point. When you're locating it, if you feel you're having trouble finding a location that's safely away from other hazards, then I would recommend a study for sure.
Okay. And then I'm going to do my last question, audience question, before we move on to the next slide, and then we'll do some more audience questions as well. But I'm curious. I'm going to give this to you in kind of two parts here, Jim. The first is there a sort of correct ratio when it comes to water and electrolytes? And then also, in that regard, do you have any reference material or maybe websites or anything like that that you feel are good sources to learn more about the ratio between, hydration and ensuring optimal electrolyte intake?
Yeah, so electrolytes are really, really very fascinating and endless subject to get into. I think the key points with regards to electrolytes, number one is everybody loses electrolytes at a different rate. And so I would recommend the Gatorade Sports Science Institute has, a lot of this work has been done in athletes because they sweat a lot, and their physical performance has been studied in such great detail. They've found we did some joint research with Gatorade, and we found that there can be up to a 22x difference in extreme cases in the sodium loss among similar athletes doing similar workouts, and it's really comes down to individual factors. So having individualized monitoring at a baseline is important. Some people maybe fine the whole day without specific electrolyte supplementation. They're just getting enough from the food intake. Some people may need, electrolyte supplementation every time they take fluids, and it really depends on their specific, whether they're a salty sweater or not a salty sweater, and
Wow.
that can be determined fairly easily through personalized monitoring.
Wild. Well, let's start talking about hydration a bit here. Next topic, monitoring heat versus monitoring hydration. I think a lot of attention has been placed on monitoring heat and maybe even humidity, but not as much emphasis has been placed on actual hydration. So let's start off. What's the difference between monitoring the environmental heat versus monitoring worker hydration?
Yeah, and I think this, obviously you have to monitor your environmental heat and humidity. The wet bulb globe temperature is a key input into your heat stress program and adapting it on a day-to-day basis depending on those conditions. But what we've discovered is there's so much individual variability in response to temperature and humidity, and that can vary based on so many factors, from genetics to age to the physical condition, diet, and so obviously everybody measures WGT. We look at the heat index. That gives us sort of a broad picture of risk, but I think you still have to consider risk on an individual basis by monitoring, having a system in place, certainly for high risk workers, to monitor hydration in each worker.
All right. So, and you kind of hinted at this before, why might traditional heat index or wet bulb globe test metrics fall short in protecting workers?
Yeah, and so we've actually done tests where we've put individual hydration monitors on people and examined their physiological response and determined what their actual risk level would be, and compared that to the NOAA heat stress risk levels. And we found that in almost every case, the individual workers were at higher risk than the heat stress, so the heat index would have indicated. And so, the heat index obviously is an important input, as I said, but because it's based on population averages, it doesn't take into account the specifics of the site or the specifics of individual workers. You really need to augment it with individualized monitoring.
Okay. And then how does hydration data provide a more actionable layer of insight?
Yeah, and this is the important thing about having a hydration monitor that each individual worker can apply to as a wearable. Um, it gives you two levels of safety. One is similar to a gas monitor. It's going to set off an alert directly to that worker to let them know that they're heading into the dangerous zone of dehydration. It'll set off an alarm quite early in the, they lose 500 milliliters of water. It tells them that. And so, it's really preventative as opposed to a lot of, heat stress programs, which are really out there, they're trying to prevent those acute injuries. It's important that the data is actionable directly by the worker, similar to a gas monitor, it gives them the direct feedback. But at the same time, it's collecting data from all the workers, from all the sites, feeding it back into the safety team so they can identify trends and then feed those trends back into their heat stress prevention program so they can discover hotspots, they can discover certain types of work that lead to higher risk, certain types of conditions. Those could be environmental, they could be weather conditions. So all those things, having that data and collecting that data over time is really valuable.
All right. Well, let's get into some more audience questions. And I got to laugh. I'm just going to say to everybody out in the audience, you guys are great. I'm looking at the questions coming in, and so many of them are related to the slide deck that I put together. That we've got a good parody going on, everybody. So if I don't ask your question immediately, don't worry, it's coming up. So at any rate, this is a good one. Earlier, you talked about acclimatizing people, Jim. And so this person says, we've recently made a change in our attire requirements, right? So we've gone from long pants and long sleeve shirts and that sort of thing to shorts and short sleeves, and we've made this change. But is there anything else we can do to help acclimatize people? How the tire is one thing. Is there anything else that we can do to kind of make a baked-in way to get people acclimatized quick?
Yeah, there's a lot of different things that you can do, and it really depends on whether that's practical for your particular situation. But so we just, as I said, we finished up the summer season in Australia just now. We're doing our data recaps with our customers there. And one of the things that they found they had to do with people coming on board early in the season, or Australia actually imports a lot of labor from Europe. So because Australia does have labor shortages, especially in the mining sector and the construction sector, they'll bring in seasonal workers from Ireland, Northern Europe, and they'll come straight from pretty cool environment to 110-degree desert. And what they've found is obviously sort of ease into the number of hours spent doing strenuous work in the hottest conditions. And so they would shift the work type. So they would take the most physically strenuous work and shift it to later in the afternoon when the sun had gone down, or early in the morning before it had gotten that hot. Then they would pair them up. So they would have kind of a buddy system. So new people who were coming in who weren't acclimatized would be paired with people who are already acclimatized, and just told, hey, keep an eye on them. They may not realize how quickly they're dehydrating. So those are different things that you can do depending on if the work site and the job conditions allow it.
Okay, all right. And a related question: do you have any experience or thoughts on cooling vests or cooling clothing? Anything that can help people stay cool. That's a tire.
Yeah. So these are great products: cooling vests, cooling attire. There's now quite a few different products out there. Some of them you've probably seen contain a gel that you cool ahead of time. and put it on, and it'll last a certain number of time and a certain amount of time till it heats up. That's great for keeping the temperature, the body temperature down. They have some new ones that use an electric effect sort of directly on the skin to lower temperature. Anything you can do to lower temperature is helpful. But even if you're keeping the body cool, you're still losing fluid, and so it's important to combine that, have a combined strategy of looking at hydration and temperature.
Okay, all right. And then this next one's a bit about mindset, and it's talking about the fact that there's just sort of, it seems like a constant concern about heat stress now, almost year round for some companies.
Yeah.
How do they adopt a more sort of vigilant mindset?
Yeah, I think it's. Part of it is cultural, so it's really important to know that, as you said, heat stress, depending on where you're located, the climate, the building, the other sources of ambient heat or sources of radiant heat, all those things factor into it. And so one thing is to get out of the mindset that heat is a summer issue. I think the other thing is you need data, right? So I learned a long time ago. I wish I could attribute this. I forget who told me this nugget, but you can't improve what you're not measuring, right? And so it's really important to measure and know, what is the state of people's exposure to heat stress, and you can do that partially, by keeping track of things like the heat index and WBGT. But as we said, there's so much individual variability that having a personalized monitoring and data collection program in place just helps give you that additional, it gives you that day-to-day data. You can see, are you getting better? Are you getting worse? Where are the areas that you need to really improve? Where are the areas that have very high risk?
Okay, all right. Okay, so, and then here's another one that's related back to the clothing, and I'm just going to go back to it because it's seeing as now apparently I'm on a clothing jag, but let's just go with it. And that is, we require our workers to wear safety vests. Could that possibly be contributing to heat stress? And I think that's kind of a loaded question because, not necessarily a loaded question, but it's a toughie, right? Because they're both primary concerns.
Yeah, it really, so when it comes to clothing, safety vests, but also just PPE in general, it really comes down to, what is the material made of? How much surface area is it covering? And what's the physical weight of it, right? So those are the three things that are going to contribute to heat stress. So, in some cases, I think safety vests, if you're talking about a very light nylon reflective safety vest, it's probably not going to contribute that much. But if you're talking about, anything that has weight to it, anything that's not a breathable fabric, then yeah, it's certainly going to trap heat. It's going to prevent the evaporative cooling effect of the sweat evaporating off the skin. To keep people cool, the number one way we stay cool is, we sweat, the liquid evaporates, it takes heat with it. And so all types of clothing that interfere with that process are going to increase risk.
Okay. All right. So let's go on to the next slide. We've talked about monitoring heat. We've talked about monitoring hydration. And let's really get into the meat of what today's topic is about, which is the case for individualized hydration. Why is personalized monitoring? We've made the case for why monitoring hydration is important, but why is monitoring personal hydration so important, and how might that affect safety? And also, let's talk a bit about the variability of it. So, starting off, let's talk about sweat rate variation. What's the science behind why one size fits all, hydration monitoring doesn't necessarily work.
Yeah, I think it goes back to, we had the question on electrolytes as well. And, through our work with the Gatorade Sports Science Institute, we've seen that, there can be, up to a 20x difference in sweat rate as well among individuals under the similar conditions. And again, a lot of that can be genetic. It can be, as I said, age, physical condition, diet, all sorts of things affect it. But the takeaway is that you could have two people working next to each other, and one of them could lose, 500 milliliters of water in an hour, and the other one could lose, 2.5 liters of water in an hour through sweat. And, there's really no way to know that if you're not doing individualized monitoring, and there's really no way for the workers themselves to know that. And so if you have fixed water breaks every X minutes, you're going to cover a good percentage of people and keep them safe, but you're going to have outliers who are not going to be safe with that approach. So that's the key reason.
Okay. All right. What kind of variability do you see between workers in the same conditions?
Yeah, that's what we just showed. So in our work with athletes, we've seen up to 20x. But in terms of the field data we've collected from our devices, over the past several years, it's not unusual to have, two workers in the same crew working at the same site, doing similar level of physical activity. Our devices also measure physical activity, and they could have, 6x difference in sweat loss over the same period of time. So that's not uncommon. Yeah.
Okay. All right. And then, so looking at that, knowing that there's this variation, and knowing that you should, monitor it, how should that change the way that safety professionals and employers think, and the workers themselves think about heat stress prevention?
Yeah, I think, there's two key aspects to the personalized approach. One is, as we mentioned, it allows you to not leave the outliers behind. To not leave them unprotected. The people who are heavy sweaters, the people who maybe have, even if you're not a heavy sweater, we've also found everybody has a different thirst response, right? So there's a good percentage of the population that don't feel thirsty even after they've lost 2% of their body weight in fluid. And so the way you protect them is the way we do it is we've created this device, which you can see up here. And it tells the worker how much fluid they've lost exactly in ounces. So they know how much they've lost. And that leads to the second, I think, more important point is that it empowers the workers. So when we think about monitoring devices, often we think somebody somewhere, at a remote location is monitoring. That's not really our approach. So it's a monitor in the sense of a gas monitor, where it tells the worker directly when they're in danger. So there's no need to have somebody looking over the data and getting alarms and running down and saying, "Hey, you're not drinking enough." When you've lost a bottle of water, 16-ounce bottle of water, the device will actually vibrate on your arm, and that'll let you know you've lost a bottle of water. And you might be like, "Oh, I'm busy, I'll get to it." If you hit that danger zone of 2%, it gives you a really strong vibration that you can't ignore. And so because it's giving direct feedback to workers, it improves the workers' own hydration hygiene. Over time, they realize, I may not feel thirsty, but the device, it's measuring, I lost a bottle of water. If I follow the advice of the device, and if I drink when I feel the vibrations, I feel better at the end of the day. I don't get cramped. I don't get tired. I don't get headaches. And over time, we find that, this is the bigger effect. Obviously there's the protective effect of not leaving those outliers unprotected, but there's also the empowerment of the worker.
That's an interesting one. And we've got some questions from the audience in line with that. and I'm going to dive into them. But before we do, somebody had a question that I thought was an interesting one. Is it possible to monitor intracellular hydration?
That is a really good. I mean, that's like the $1 million question.
Aha.
So I think what you're getting at is there a way to somehow have a device that tells you how hydrated you are right now? Like, so the personalized hydration monitor that we provide will tell you how much fluid you've lost.
Yeah.
But it's not like going into your body and seeing, currently right now, what is your water to mass ratio, or how hydrated
Yeah.
are you at the current moment? And that's an incredible science and technology question. We've looked into it. There's a lot of research out there, but there are some devices that use electrical impedance across the body, with electrodes at the feet and the hands. They tend to be off by up to 50%. It's really hard, because the body consists of so many different tissues of different densities. It's really almost impossible to come up with a device that would tell you accurately, like, what is your current state of hydration. And so our device says, how much fluid have you lost? It's very simple. It's easy to measure. And if you put back what you've lost, you'll stay hydrated.
Yeah, it almost kind of reminds me of like a continuous glucose monitor, right? It's like I imagine there might be a way to do it, but the end device might get a little spendy. And
yeah, I mean, glucose
yeah.
is easy because it's a substance, it's a molecule that exists in your blood. You can just look and see how much. It's like we measure sodium concentration,
Yeah.
very accurate. But hydration is how much water is in your body right now as a ratio to your total body mass. I mean, just think of that science problem. Like, how do you figure that out with a device? Yeah.
Yeah. All right. Well, anyway, it was an interesting one. Okay, so now talking a bit about, like we mentioned, being able to individually monitor workers is an empowering tool. So let's talk a little bit about that. How do you and somebody had a good question, and it was, oh yeah, how do you prioritize the use of that efficiently across a large worker population? And I think they're thinking more logistics, not cultural, but more like, how do you identify maybe more at-risk workers and sort of stage it where you really have to think about doing a rollout kind of individualized hydration monitoring?
Yeah, this is a great question, and I think it's similar to other types of safety, personal safety monitors, wearables. There are ways to gauge relative risk, and so obviously the first factor would be exposure to both environmental temperature and radiant heat sources. That would be probably the number one thing you'd look at. And then you can narrow things down from there. So there are factors that increase the risk. So as I mentioned, the clothing, PPE, the type of work, the level of physical exertion required, and then acclimatization status. So we have customers who they may have 18,000 workers. They don't put a hydration device on everyone, but they'll have a heat safety program in place where they say, anyone who's unacclimatized coming onto a new site, they wear a heat safety device for the first summer. And anyone who is, working in temperatures that exceed 90 degrees, they all get one. Anyone who's wearing full body PPE, they get one. If you're working close to the furnace, you're working close to a radiant heat source, you get one. So you can identify those workers who are at most risk and focus in on them.
Okay. So now this is a question that often comes up with wearables and individual monitoring, and that is, some workers might feel that monitoring their sweat is almost like sharing private medical data. How does the system protect individual privacy?
Yeah, excellent question again. We developed this product together with Chevron. So Chevron is one of our biggest investors. They invested in the company quite early. They also provided funding for us to develop this product, and they tested it in the field for years before we released it. So they've been our close partner, and one of their absolute requirements was, hey, we don't want the liability of having protected health information. We don't want to know, personal details of the workers who are using these devices. So we designed the platform to be completely secure, and the data is anonymized. So when the individual person wearing the device has access to all their data. There's a smartphone app. They can pull it out at lunch, take a look, see how they're doing. They get that feedback through the device itself, through the vibrations. But when the data is uploaded to the cloud for the safety team to look at, it's anonymized. And for Chevron, we had a further level of protection, which is we provide them only with group level data as opposed to individual device data, just to make it very, very clear that nobody is looking at, nobody's going to run down onto the site and say, hey, Steve, I noticed you're not drinking enough. The device told me, you got to keep that data is not available, and that's by design. We just the way we reassure the workers is basically, the data isn't there. The employer does not have access to that data. And there are certain subsets of use cases where it's necessary. So for example, firefighters. In the case of firefighters, both the firefighters and the management do want that data to be identified. And so we have the ability on the system to turn identified data on, but by default, it's off. And you have to tell us you want it to be turned on. And that means you have to get the buy-in of all the workers.
There you go. And that's probably the best way to handle it anyway. So, all right, now let's go on to the next set of questions. And this is about, it went a little bit, no, actually I got it right there. Sorry about that. And that is, let's talk about this technology now. So we've talked a bit about individualized monitoring. Now let's look at your approach. And for everybody who had questions in the audience about this actual technological solution, I haven't been ignoring you. I've just been sitting on your questions. So let's dive in. And Jim, maybe in practical terms, you can explain how the connected hydration system works on the job.
Yeah, so the quickest explanation is you can see here in the photo, it sticks to your outer bicep. And we also have an elastic band version, like a stretchy band, which in cases where you don't want to use an adhesive patch, so that's another option. But essentially, it sits on the skin directly. As you sweat, it measures the sweat that passes out of the pores in real time. So it's actually directly measuring sweat loss. And then it also samples the sweat for sodium concentration as well. So we can see how much sodium you're losing. And so from the moment you put it on, it's telling you how much sweat you've lost since then. As you start to become dehydrated, as I mentioned, when you lose 16 ounces of water, it'll vibrate. And then you can drink a bottle of water and you press that button, the big one. There's the small button is power. The big button is I just drank a bottle of water. And so it will kind of reset you back, assuming you drank a standard 16-ounce bottle of water. And you can, it's customizable. You can say the button is, whatever, a 8-ounce bottle or a 1-liter bottle, whatever you want to do it, you can map it. But the key is to make it super easy to follow, right? So vibrate, drink, and you're done. Vibrate, drink, press button, and you're safe. What makes it different is that there are solutions out there that are, advertised as heat stress wearables, heat stress prevention wearables, heat injury prevention wearables. They tend to be reactive, and because they're measuring heart rate and temperature usually, maybe they might be measuring activity level through an accelerometer, which we also do. By the time your heart rate's up and your temperature's up, you're in bad shape. you're at the point where like you need to come out of the field, you need to sit in a cold truck, you might even need to go to the hospital at that point. And so while those solutions will prevent acute injuries, they're not going to intervene at when you've lost one bottle of water. They're not going to keep you hydrated. They're going to maybe keep you out of the hospital. And so the importance of keeping you hydrated is, even early on, as you start to lose fluid, as I mentioned, you get tired, you become less productive, you become more prone to headaches and cramps, and you just don't feel great. And then you start becoming prone to other types of injuries because of that cognitive impairment that kicks in. And, these other solutions that are out there, they're not going to catch heat stress that early. So I think that's the big difference with a hydration monitor as opposed to a heat stress monitor.
All right, and you sort of, excuse me, I think you maybe you answered my second question here, which is what makes this different from other wearable tech solutions out there. So going on then, how has this system been tested or validated? You mentioned that you guys worked with Chevron. Maybe you could tell us a bit about that.
Yeah. So as I mentioned, Chevron invested in our company. So did Gatorade, PepsiCo. They invested in our company. We've done a lot of work with both of them. But for the connected hydration device, really this came as a request from Chevron. They saw the work we were doing with Gatorade, with athletic performance and sports. And they said, our workers out there are really industrial athletes. They work out just as hard, in some cases much harder than football players, and they deserve the same level of technology, keeping maintaining their physical performance and keeping them safe. And could we take the work we did with Gatorade and turn it into an industrial safety product? And so we worked with them for it's coming on 4 years now. They gave us the requirements. Like I said, it's absolute data privacy was one requirement. We already talked about that. Class 1 Div 2, it was a non-negotiable for Chevron. It has to be Class 1 Div 2. So our device is Class 1 Div 2 certified. They wanted it to work without any kind of data connection, or they didn't want the worker to have to carry a phone around all day and get messages on their phone and then look at them and then take a drink of water. So we designed it so that the device itself provides the feedback through those vibrations. There is a phone app that the worker can open up during lunch or at the end of the day to get real detail, you lost, you drank, here's the sodium. They can look at that, but it's not required to take advantage of the safety features of the device. And so, they had a lot of remote sites with no internet. It has to work without internet, so we designed it that way. Mm. So all of those things fed into, all those Chevron requirements fed in, and we put prototypes out into the field. They tested them. They gave us feedback. We improved it. So over the course of 3 to 4 years, we refined it to the point where about 1.5 years ago, we released it as a product that anyone could buy. And of course, Chevron continues to buy them from us and use them around the world. But yeah, if you can, it's sort of like the New York song, if you can make it with Chevron, you can make it anywhere.
All right. Well, we've got some good questions about the devices and about this system. So, excuse me, let's dive in. One of the first questions is, you mentioned that it can stick on or you can strap it on with an elastic band. When it comes to the stick on, is the adhesive patch replaceable?
Yeah, so the adhesive patch version that sticks on, the module, which you can see here in the photo, the center part of it, the center oval, which is a little bit smaller, you might be able to see in the photo at the top of it, there's a little latch. So if you pull that, the module, the electronic piece pulls out and disconnects, and the patch, the adhesive patch, you peel off and you throw that away at the end of every shift and put a clean one on in the morning. So, and the adhesive we use is a 3M surgical grade adhesive that has been tested for, hypoallergenics. So it's used in medical grade products around the world. And it sticks really, really well, even in hot, humid conditions. But yeah, we did get feedback from Chevron that in some cases, they would prefer to have the armband, just because it's easier for the workers to put on and take off. You don't have to make sure you have an inventory of patches available, and it becomes essentially the entire thing is reusable. There's no consumable piece to it. So we offer those as both as options.
Okay, all right. And just so everybody knows, we got about 10 more minutes left in the discussion. I'm going to corner a good bit of the discussion about the device because it's fascinating stuff. But we do have a couple more slides that we'll try and get to. So bear with me, everybody. This is an interesting one, and do the devices need calibration? Like, do you have to, since it's user-specific monitoring, do you have to do any sort of user-specific setup?
Great question. Yeah. So the device itself doesn't need to be calibrated because it is looking at the flow rate of the sweat passing through it. But the way the calibration that it does need is when you first set the device up with a worker, they just have to input their height, weight, age, and gender. And that just gives us a little bit of more detail. Well, the height and weight is the important part because then we know we can take that local sweat loss, which we're measuring on the arm, and we can extrapolate it to the full body sweat loss. But you do that once at the beginning when you set up a device on a new worker. And the devices can be shared, so you can, for example, you do turnarounds. You have a group of people using the devices for a few weeks, and then they'll take them off. You can, use them with somebody else. You just do that setup one more time when a new worker starts to use it. But other than that, the device itself doesn't need to be calibrated.
Okay. What is the battery life on the device? And in fact, I'm going to add just what's the life limit on these devices in general.
Yeah, so that was another Chevron requirement. They didn't want to have to recharge the device, so they didn't want to have 1,000 chargers, in the doghouse where every night, don't forget to charge your device. Like they didn't want any of that hassle. So we went with a sealed battery and ultra low current consumption components. So we designed all the components to be like really, really low current. And so the battery will last 1,200 hours in between replacement, and we do the replacement. So usually 1,200 hours will get you through, even if you're using it every day, we'll get you through 6 months of use. And if it's seasonal, then, once a year we would replace it. And if you're using them year round, we'd replace the battery twice a year, but that's all part of the service we provide.
Okay. All right. And then this is an interesting question, and I think gets to the heart of it. You talked a little bit about the process, but what is the basis of the detection method?
Yeah, so we detect, I actually skipped over this, so great question. We have multiple sensors in the device. Obviously, the primary sensor is sensing fluid loss. Then we're sensing sodium concentration. We also have 2 temperature sensors, so we measure skin temperature. We measure ambient temperature, which is the temperature at the surface of the device. So that would be air temp, and that could, if you're wearing PPE, that allows you to measure under PPE temp continuously. And then there's an accelerometer that measures activity level. So all that data is recorded every 20 seconds. So you'll get 20-second granularity on the data as long as the device is on the arm. In terms of the methods, I mentioned, temperature, accelerometer, those are standard sensors. For the fluid, we actually have a microfluidic architecture on the underside of the device that channels sweat through a series of microscopic channels. And along those channels, we have detectors. And so based on how quickly the sweat is moving through the channels, we can determine the speed, the sweat rate, and how much sweat you're losing per unit time. And that's part of our patented technology. You can go to the US Patent Office website and search on Epicore, see how we do that. And then the sodium concentration is an electrochemical sensor using electrodes.
Okay, all right. Let's go to the next slide. We've got about 5 minutes left. We'll see if we can answer some good ones. I might skip a couple of mine here in favor of the audience. In talking about rolling out this sort of thing, so if somebody's interested in this, they review the systems, they decide they want to go with it. What are the first steps that the safety team should take, in considering this sort of thing?
Yeah, I think it goes back to, we talked about the risk level. And the first thing I would look at is the level of environmental heat exposure. And that could be just simply outdoor temperatures if you're at an outdoor job site, just based on the heat index. And then other factors like PPE use, exposure to radiant heat sources, and then level of exertion. All of those things, I think, if you have workers that fall into any one of those categories or where those categories overlap, I think that's where you would do your first pilots. You can start a pilot with 10 or 20 workers, and the results that we look for are first, the data. So like just understanding how quickly people are sweating, how quickly people are losing sodium is data that you probably don't have today. But the other effect that we look at, even in a 4-week trial, is the educational effect. Like, are people hydrating more? Are they hydrating earlier? Are they staying hydrated? And do they feel better? Do they cramp less, headaches less fatigue? So that's what I would look at.
Okay.
Do you want me to go to the next one, the being monitored?
Well, actually, no. I'm gonna give you a two-parter here. I'm gonna mush an audience question into this one, and that is, how do you get buy-in from leadership? How do you get buy-in from the team? So let's talk about upstairs, downstairs, right? Or maybe that's sort of upstairs and laterally. Yeah.
In our experience with upstairs, money talks. So, I think one of the overlooked aspects of heat exposure is the effect on productivity. And, when people feel fatigued, when they feel cramped, even if you don't even consider the economic cost of acute injuries, which, it can be over $100,000 per injury where a hospitalization is required, and then compound that with remote sites like offshore rigs where you add a helicopter into that, a medevac, and like already, if you can avoid one of those every 2 years, you've paid for it. But, even if we ignore the acute injury prevention, just the day-to-day productivity improvements that you'll see, and you can quantify that, is enough to justify and more the investment. From the downstairs, we shouldn't really say upstairs, downstairs.
Yeah, that's the wrong way to phrase it.
from the people out there in the field doing the hard work, it's an additional layer of safety. This says, hey, look, we don't want you to get hurt. We don't want you to go home with headaches and so tired that you can't play with your kids. And, this is something that will keep you safe. It's a safety device. It's not a monitor. It's a safety device. And the data that we see is anonymous. It's data that we use to keep you even safer, but we're not seeing anything related to your personal device. We don't know what device is being worn by what person. These are to keep you safe. And because the device is designed to give instant feedback directly to the worker, just like a gas monitor would send off an alarm when there's a dangerous situation and keep the worker safe, same thing. So I think once you explain it that way, I think people get it.
All right. Okay. All right, and then let's wrap it up with this final question. Any sort of key lessons that have emerged from deployments? Maybe you got some feedback from the workers at Chevron, or maybe other customers that you want to share. Any sort of final thoughts, let's say.
Yeah, one thing that was a real eye-opener for us is, I don't know if anybody in the audience attended the Connected Worker symposium and conference down in Houston last month, but the Chevron safety team from San Joaquin Valley, one of their sites, was there. The safety manager presented, and he said for the first time in 4 years, they had 0 SIFs after deploying our devices. So that was something that was an eye opener. I mean, we knew to expect positive results, but that's really something that's quantifiable. But we do quantitative, so we'll interview people, the workers, after they've been using the devices for 6 to 8 weeks, and we get comments like, I feel safer. I don't get as many headaches. I didn't realize how much water I was losing. I would just drink when I felt thirsty, but when I drink when I feel the buzz, I feel better. So a lot of that may be harder to quantify, but that's I guess the best way to quantify it is when we do limited trials. So sometimes the customer will ask us to come in for 6 weeks and we'll try it. At the end of the 6 weeks, you got people saying, "I don't want to give it back. Can I keep it?" And I think that's the biggest endorsement.
There you go. All right. Well, guys, we're going to have to wrap it up there. Once again, I want to thank our expert speaker, Jim Ryan, Chief Revenue Officer of Epicore Biosystems. Jim, thank you so much.
No worries. Thank you for having me.
And thanks again to our sponsors for today's webinar, Epicore Biosystems. Many thanks to them for making today's Q&A presentation possible. With that, we're going to start signing off. Remember, in the next day or two, we're going to send you guys a link to an archived version of the webinar so that you can view it and maybe share it with a coworker. Also, as a heads up to everybody, under that resources tab, my coworker Tammy, who is always in the background making sure that everything is working and coming off without a hitch, she was able to add the heat stress guide that Jim mentioned to that resource directory. So if you click on that resources button, you can find it. You might have to refresh your browser, but it is in there. So just, if you don't see it, refresh your browser. Okay.
Or you can snap that QR code too. That's right there at the bottom.
Yeah. Yes, indeed. Thank you, Jim. Yep. It's so that QR code that's on your screen will help you as well. Okay. Last but not least, thanks to all you out in the audience who participated with us today. You guys are the reason that we do this. So thanks very much for all the interest and involvement. With that, we're going to sign off. I hope everybody has a great rest of the week. But for now, goodbye until the next occupational health and safety webinar.